Welcome to Admin Network Policy from Alpha to, Cluster Network Policy from Alpha to Beta and beyond. I'm Dan Winship. I work at Red Hat on various Kubernetes SIG Network stuff, including the Network Policy API group.
Hey everyone, I'm Surya. I'm also an engineer working at Red Hat and OpenShift Networking. I'm leading the Network Policy API working group. Happy to be here today.
Hi, I'm Bowei from Google. I'm also working on network policy. And then?
Hi, my name is Nadia. I work at NVIDIA on Network Policy API.
Cool, so let's get started with our talk. I'll be doing the past, which is sort of a recap. Nadia and Bowei will be doing the present of all the cool things that our community has done, and Dan will be doing the future. So starting with the V1 Alpha 1, how many of you are using Admin Network Policy here? That's 2, 3, good, because we have some breaking API changes, so it's better if you don't use it in production today, which is basically the takeaway of our talk today. Some of the use cases, why did we do Admin Network Policy API? And I keep calling it Admin Network Policy, and Dan said it's Cluster Network Policy. You'll see why in a moment. It's because I'm talking about V1 Alpha 1 API, where it's still called ANP, Admin Network Policy. And in transition, it'll become Cluster Network Policy through the talks. So don't get confused for that. It's the same thing. The first use case is obviously very obvious here, that network policies were designed for application developers, tenants. We needed something for admins, and hence we did the cluster scoped policy API, which is the Admin Network Policy API, and it was done to help admins be able to do policies to isolate tenant workloads in the cluster, which is cluster-wide, non-overridable by the network policies. Other use cases could be to be able to put policies around the infrastructure services, like being able to say that allow all traffic from your monitoring namespace to egress always to scrape metrics from your workloads. And this cannot be denied by any tenants who own the workloads. And the same way to allow always all ingress to DNS, for example. And another nice, neat use case is the interaction with the network policy itself. So as an admin, you can put policies that say, I'm delegating the final action of this policy to my tenants, which means it falls down to the network policies. And we'll see this in a moment later. So that's another use case. And also we have a guardrail API, which lets you do a default deny on your entire cluster. And these use cases were achieved mainly in V1 Alpha 1 using 2 APIs called the ANP and the BANP, which is Admin Network Policy and BaselineAdminNetworkPolicy. Policy. And these are 2 APIs together, and they are commonly known as the V1 Alpha 1 ANP. We are a small community. We live in the Kubernetes SIGs repo. We are currently in our alpha journey in the API versioning system, and we are on our way towards beta. We have our latest release, which is 0.1.7, V1 Alpha 1, but do not use it because it's going to break when we go to V1 Alpha 2. And that's the evaluation tier system that I mentioned. So if there's any confusion with the 2 APIs that I mentioned, just a recap that ANP is the cluster admin API. That's what gets evaluated first. So if you put your ANP rules in your cluster, you hit them. And then if you don't have any of them, or if you have the delegation action, which is also known as the pass action, you fall down to the network policy layer. And that's the developer layer, which is the core API, network policy API. Our working group also owns and maintains that, but that lives in the core Kubernetes repo. And then if you don't have any network policies defined by the tenants, we fall down to the baseline admin network policy, or if there is no match on that layer. Baseline admin network policy is also a singleton object, and that's like the default guardrail in the cluster. And you can see that this is basically going to vary when we go to V1 Alpha 2, so just keep this diagram in mind, and Nadia will talk about it later. And this is an example of how the ANP V1 Alpha 1 looks like. There is a priority field, so you can have many ANPs, and each ANP will have a priority. That's how it's decided which one gets evaluated first and which one is, the precedence, basically. And within each ANP, you can have ingress rules and egress rules for ingress traffic, egress traffic controls. And the precedence of the ordering of the rules is important because it's evaluated in the order in which it's defined, which is very same to network policies. That's another example. So what you see here is the pass action. So we have 3 types of actions: allow, pass, and deny. allows, and pass is just going to delegate it to the next layer that I mentioned, which is network policy layer, and then you have the deny. And I'm skimming through the BANP here as well, but you can pretty much forget about this because this is not there anymore in the V1 Alpha 2. I don't want to spoil the surprise. But it's just to do a recap so that you can see the changes in transition when we do what actually broke, right? You need to know what exists now to know what breaks. So the BANP right now is the singleton object that I mentioned. It does not have a priority because it's just one object that you get to define for your entire cluster. And everything else is kind of same like the ANP, but you don't have a pass action because there's nothing to fall through to. For V1 Alpha 1 adoption, we've had quite some implementations and good progress and healthy community. We have been gradually improving our feedback mechanism. So the first adopters were Antria CNI, Innovian Kubernetes CNI. We've had Calico and Cubovian implemented since, and Cilium is in progress of implementing it, though they might actually end up implementing V1 Alpha 2 instead, which makes sense. We also have our very own Kube network policies. Antonio is here in the audience. He's the main author here. And that's our very much homegrown implementation with which we test everything. So that helps us ensure that our API changes are conformant. So every time a plugin implemented our V1 Alpha 1 API, we got good feedback. We did iterative changes. And for most parts, this API works fine. But the reason why we decided to break it was because we wanted it to be more simple. The fact that we have two different APIs, two different CRDs, which pretty much have 95% of the fields exactly the same didn't make sense because there was a way that we didn't need really to do that, right? So that was mostly the reason why we did that. But technically speaking, nothing changes. Like whatever you could do before, you can still do the same things. So why did we decide to do the breaking changes now? So this API has been in V1 Alpha 1 phase for 3 years approximately. And we want to continue this API towards its beta journey relatively sooner. Dan will cover more details around that. But that's why we basically decided that it's now or never. Let's iterate and get this API solidified. And we have decided to cut a V1 Alpha 2 release. We haven't cut it yet, but I'm going to pass the mic over to Nadia, who'll talk more about all the cool changes that has happened since the V1 Alpha 1 phase of our API.
All right, so we'll start with the first breaking change here, which is the cluster network policy is now a single API that replaces both ANP and BNP. So this is how it used to look like before. We have 3 different tiers here that are evaluated top to bottom. And you would start with admin network policy that is controlled by admin. Then network policies would be evaluated that are created by the developers. And then there is the guardrail baseline admin network policy at the very bottom. So as was mentioned many times, admin network policy and baseline admin network policy, 2 separate objects. Now, there is just one object. It is called cluster network policy. We're going to be referring to it as CNP. Please get used to that. And basically, the main difference is it's the same object, but the admin and baseline tier is now a field, as you can see here. So the top one is tier admin, and the bottom one is tier baseline. So hopefully, it will be easy enough for you to adjust. Now, while ANP and BNP were very similar, they were not exactly the same. And not necessarily because we really wanted it that way, but because we just didn't have enough use cases for the baseline tier. But now, when we joined these 2 APIs into one, baseline tier kind of inherently got some nice new features. First of all, it is not a singleton anymore, and it also has a priority field now, same as admin network policy used to have. So both of them have priorities now, and you can have multiple admin network policy and baseline tier policies. Another good feature is the pass action that used to only exist in admin tier and now exists in both. So originally it means that admin tier, when you hit a pass action, it will go to the next tier, which is network policy. Now, underneath the baseline tier, there is still one kind of invisible tier, which is allow all, which is also the default policy in the cluster, usually if you don't have anything installed. So What pass action in baseline tier does now, it just skips all the evaluation and goes straight to that default tier. And another one, which is the experimental egress peer type that was only supported with admin tier before at domain names. It is still experimental now, so that part didn't change, but it is also now available in baseline tier. Now, what do I need to do with my YAMLs, you may ask? The change is fairly simple. You can see that the whole difference for admin here is you change the v1 alpha 1 to v1 alpha 2. The kind changes from admin network policy to cluster network policy, all as discussed. And the only new field is tier admin now. That's all you need to do. For the baseline, as mentioned, there is one extra field now, which is priority. If you used to have just one, you can put whatever there. But if you want to create multiple baseline tier policies, you can do that now with the priority field, same as with admin.
So here are a couple. Okay, so here are some examples to go through in terms of how these policies interact between the different tiers. So if you see on this diagram, we have admin tier at the very top, then your standard network policy, this is the current network policy that you have, and then the baseline. In the case where you have no policies configured, this will be the default Kubernetes disposition, in which case your traffic will just get accepted. Now, if you configure an existing network policy, such as in this case, you have a pod with a label app equals web, and the network policy matches app equals web, it will match the network policy, but you can have any baseline here because network policy will take priority in the evaluation order. Finally, this is the thing that I think a lot of people have been asking for a baseline, is that you can put a baseline action deny if there are no additional policies configured. In terms of the admin network policy tier, and this applies to baseline as well, there is a priority order. So a lot of admins have like a stack of different policies they want to apply in some priority order. So first, the admin, in this example, it's a deny policy, will evaluate the policies from priority lowest number to highest number. And you'll see here in this example, priority 10 did not match, and then priority 20 matched, it was a deny, in which case the traffic is denied here, and then any further priorities are not evaluated. And of course, given that this deny had happened in the admin tier, any network policy could have been configured, any baseline would have configured, but those would not be evaluated. The same thing applies on the accept case, where basically the priority order is evaluated, and then in the admin tier, this traffic is accepted right away without looking at all of these other policies below. Finally, the pass is a little bit complicated. So if you configure a pass in the admin tier, let's say this is the same example where priority 10 did not match, but priority 20 matched. If you say pass, what will happen is that the evaluation will skip the rest of the admin rules and go to the other tiers. So in this case, you have a pass matching at priority 20 in the admin tier, and then it will go to look at the network policy tier, in which case there is a match. Similarly, this is an example of an example where there is no network policy that was configured, but you did put a baseline that basically denies. And the other thing to note about this example is that the baselines also have priorities. So this one matches the pass, skips to the network policy tier. There's none here, so it drops into the baseline, and then finally it evaluates it with respect to the priorities. There's a couple of other smaller changes. I think most of these are ergonomic. So one is that we renamed allow to accept. So this is just to reflect the fact that allow was a little bit ambiguous, whether you are allowing traffic to go to the next tier, or you are just simply accepting it and saying, hey, we can accept this packet. So accept is a more direct thing. So the actions are now accept, deny, and pass. It's like a fairly small change. The other thing is that the original port structure was centered around ports, but as we all know, there are protocols that don't have ports. So we have been debating how to represent this to make it easier for future extensions. I think one of the most common extensions being discussed is adding something like ICMP, which is in a lot of the providers, and sort of restructuring the API for this future extension. All right.
So what's next? Assuming that we don't find any problems with the API that Bowei was just talking about, then we're going to declare that to be V1 Beta 1, and then Cluster Network Policy will be beta. According to our original KEP, we need to have 2 implementations before we can do that. We actually already have one. Kube Network Policies, the reference implementation, is basically keeping up with all of our latest changes as we change things. And so they've already got it implemented. Calico, Cilium, and Ovi and Kubernetes are all planning to implement the API once we get it figured out. When we first came up with the plan, we were hoping that this was going to be one of those talks where we'd open up a web browser in the middle and hit publish, and then announce that it was now beta. Unfortunately, that did not happen, but we are hoping that it will be beta by KubeCon in Amsterdam. And so then what happens next? There are a few things that we want to add in a compatible way after the initial V1 Beta 1 release, one of which is being able to just explicitly say allow all or deny all. Theoretically, you can do that with an IP address match, but it's a little bit tricky, and you might forget to match both IPv4 and IPv6. So we want to add explicit syntax for that. The other thing is that right now, in egress rules, you can match against CIDR blocks or against node selectors, but you can't do the same for ingress rules, and we are going to need to fix that. There's another thing we talked about, the fully qualified domain name matches. That is still experimental. We don't expect there to be enough implementations of it for it to be able to become standard by the time we get to beta, although it would be great if we could, because a lot of people are interested in that. And then there are a few other NPEPs, the network policy extension proposals. One in particular, we've talked about having a way to create an admin network policy and then not enforce it, but just have it log, I would match this packet or whatever. And there's some discussion about that. Not clear if that's going to make it into V1 Beta 1 or later. The original proposal for admin network policy had the idea of tenancy, where you could create a single rule that said something like, all pods in namespaces owned by Alice can talk to pods in other namespaces owned by Alice, but not in namespaces owned by Bob. And we had an API for that originally, and it turned out to be way too flexible and made it possible for people to create rules that just sort of exploded when you tried to implement them and into thousands of sub-rules. So we removed that at some point during V1 Alpha 1. We want to bring something back. We don't know exactly what it's going to look like. There's been some discussion that maybe we don't actually need it. Maybe people can just create a controller to automatically make new network policies as new namespaces are created. That didn't work well with the original network policy API because there were always race conditions. But with cluster network policy, you can get rid of some of those race conditions. And so maybe that will work. Or maybe everyone will just switch to using multi-cluster and do tenancy that way. Somebody's cheering back there. So we're still figuring out what will happen here. Stay tuned. Identity-based policy is another one, and there's sort of 2 aspects of that. One is just using a pod service account name to identify the pod, which makes it a little bit simpler to have very specific policies. The other idea is using TLS identity rather than IP addresses to filter out traffic. And a lot of people are doing that now with Istio or another mesh. And we had some discussion at the London KubeCon about, is there some way that we could make that work and interact with cluster network policy so that you could have a rule like, if the TLS certificate matches, then accept. Otherwise, if it's to port 80, deny. Otherwise, and have these TLS rules and IP-based rules interleaved. And we never quite figured out how that would work, so that's also still under discussion. And then at some point, there should be cluster network policy V1. We're hoping that the V1 API will just be whatever the end version of the V1 Beta 1 API is. We don't currently have a timeline on this. We need to get V1 Beta 1 out and then see if it's working for people. Once it's beta, more people will be willing to run it and try it out. we'll get more feedback. And of course, even after we declare it V1, we will still hopefully be adding more features, just in a backward compatible way.
Okay, so hopefully all these nice features made you excited, and now you want to get involved. We have a very nice community, very friendly people, so please come join us. There are a couple useful links here that you can find, some contributors guide for the Kubernetes in general, and especially if you're interested in network policy, please go check our webpage, our enhancement proposals, which are much better than the Kubernetes enhancement proposals. There are some issues with the help wanted and good first issue. Please go look at those if you're interested. And of course, we are looking for more requests and feedback. If you want a new feature, please go submit an issue, open the enhancement proposal that I've already advertised. And also, just get in touch. There are a couple links that will show you our Slack channel. Please join, ask your questions. We have a bi-weekly meeting with an open agenda where you can also go join, introduce yourself, ask anything you want. So yeah, please get involved. And that's it for now. I think we're gonna move to questions, if there are some. There is a mic, please.
Thank you. My question was about the action pass. So it passed the tire from top to bottom. I was just wondering what we should do within a single tire if you have to pass one rule to the next. I'm just wondering, maybe we should have a tire pass and a pass actions, maybe.
You're talking about this slide?
Yeah.
Oops. You're talking about this slide?
Yeah, that's right.
You want to pass within a tier?
I'm just wondering. I'm just wondering about it. Yeah. If there is a reason to pass within a tier.
Oh, pass at the bottom. So pass at the bottom is mostly a consistency thing. So the nice thing about making the tiers, so we used to have two different data types for the tiers, but making the tiers sort of like unified into one resource means that, you know, if at some point, not saying that we will, like you could add another tier down here, right, to change the cluster default. That's not happening right now. So when you do a pass at the lowest tier, it will go to the cluster default disposition, which is to accept. Oh,
My question is within a tier, let's say.
within a tier. When you pass, it basically exits the tier. So it passes to the next tier.
I'm asking what if there is a scenario need where I have to pass within a tier?
You want to skip within a tier?
That's
currently, that's not supported.
Just thinking aloud, but yeah, something to consider later.
You can only match one rule at that tier at a given point. So then that has a definitive action, and that can be either that it's allowed or it's denied, or sorry, it's accepted or denied or passed. You can't pass or jump within the same tier. Like it's always a decision that you get out of a rule. I hope that makes sense.
Pass is supposed to mean this traffic, I don't care what happens with that, or I want the other tiers to decide. So it's not a go-to for me to generate my rules in a certain way. It's a special action that is about the intent, that for this type of things, I delegate to the lower levels. And that is a decision by itself.
Okay. I'm just, like, let's say there are multiple admins operating a specific tier, and there is a reason to think there could be multiple network policies which can, like, let's say which are using labels or things like that, which can pass within a tier. I'm just thinking aloud. It depends.
There's like a trade-off between kind of simplicity of understanding and sort of how much you can express. It would be good, like, we're around after this to understand what your use case you're thinking of is. I think, at least in this current setup, we're sort of biased towards making it simple, because already if you have multiple rules configured in multiple objects, it can be kind of hard to figure out what exactly is going to happen when you look at the configuration.
I have a similar question on that note. So, as I understand it, if you don't have a pass, you just have a fall through, right?
Yes.
So let's say you're on tier 1 and you have something that doesn't match on priority 20, but it matches on priority 30, it would match, right? So what is the role of pass versus just fall through? Why would you not just imagine that you have nothing in the admin tier, you have a fall through, and you match on network policies?
Yeah. So you could, the effective effect will be the same, but what pass gives you is the admin says, for this, selection, I am willing to delegate that decision to the next tier, in this case, the network policy tier. So basically, you're effectively saying, well, it's up to the application developer within their namespace to come up with the policy. So it's like a very explicit representation of that. And you might have that match higher in priority than something else, which is like a blanket rule.
Okay.
So you can actually always express the same policy without using pass, but for that you will have to punch holes sometimes. So imagine you have a deny all at an admin level, but you know you don't want deny all for given ports or given protocols or something. So instead of writing this like match everything except for this port, so you're like punching a hole in your rule that matches that, you can have a higher priority one saying pass everything for this specific rule, so delegate, and then you can have just rules that look prettier without these extra exceptions that you would have to add otherwise.
Gotcha. So it's like saying skip all of the lower priority admin tier. Okay, thanks.
So as you were developing this architecture with the community, incidentally, I think this is a great first organization here, because this is very similar to what we even do. Was it considered that the tiers could be dynamic on their own? That instead of having static admin and baseline, that you could just have like a hierarchical set of policy orders, that you'd have like tier 0, tier 1, tier 0.1, 0.2 or something?
So the tiers were a late addition, because originally it was just admin network policy and baseline, and we wanted to get rid of that because people didn't like having the two objects. So we came up with the tier system. I think Calico has, in its global network policies, it has multiple arbitrary tiers. And so we talked about, we wanted to make it potentially extensible in the future, which is why it's tier and then the label rather than a Boolean for admin versus is baseline. So theoretically, we might add more tiers. Programmable tiers starts to get into the whole thing about simplicity versus expressibility.
Yeah, because I do think that what you've done with Pass is kind of a killer app. Like, I think that's a very, very unique feature that is going to be very powerful for us managing our clusters. But I think, as the other gentleman noted, there's not just admins. There's security admins, there's network admins, there's cluster admins, and so you're gonna have all these different groups participating in the policy. And if you're using a GitOps sort of thing, it makes it a lot easier if you use something like Kyverno or Gatekeeper or something to say, all right, well, this team can only create cluster network policies of tier network, and then you have some sort of cluster-wide policy that orders those tiers in some way. That would be even more powerful. That would be so great. It'd make it so much easier for us to organize this from a governance perspective. So if that's in the list somewhere, let's do that.
And one more way to also think about that, if you have different teams, like you mentioned, network security, other types of admin security, is to subdivide your priorities.
But then you can't.
You can't pass.
You can't pass, but then at the end of the day, you are saying that somebody might be the admin, and then someone else is a sub-admin. In that case, you can actually use the priorities to
Yeah, and that's what we do
divide
today
the
with Calico policy, is that we have gatekeeper enforced blocks of order numbers that are designated for each tier. It works, but it's very awkward. It's not very documenting. Like, you read the policies, it doesn't really obviously say that this is what you want, and so.
But do you actually use pass in this specific
you can't
tier?
use pass. That's the other thing. Is
no,
that
I mean, you're saying you do have this system of dynamic priorities, which you can implement with just slicing it to the CNP into
that's what
priorities.
we have today.
the only thing you can do now is use pass in that way to the next tier. But I'm wondering.
Pass would make their system simpler.
Yeah, if I could add pass to that,
so
that's even
you
better.
would actually use that. It would be interesting to hear about like the cases, because pass is not the most popular action, let's say.
Yeah, keep it. It's good. I want it.
I mean, we're not going to get rid of it, but I'm curious to see how many different teams all want to pass to like the same team.
Thank you.